Let's talk about quantum numbers. What's going on here is essentially you've got four of them: N, L, ML, and then MS. This right here is known as your principal, or otherwise, what shell are you in? So we could say shell number. And you think about the Bohr model, where you get to larger and larger shells. You start with just the two electrons, hydrogen, helium. You move into beryllium, lithium, boron, carbon, nitrogen, oxygen, fluorine, neon, and then you get higher, blah, blah, blah. So that's basically asking where you are. This is always going to be a positive integer, a number that is positive. Then your angular momentum, also known as your subshell. This is simply stating the orbital shape. This is where you have your S, your P, your D, and you're going to use that number. And then in order to find this, it's going to be anywhere from 0 to n minus 1. So if it's 0, that's always going to be an s orbital. If it is a 1, it's a p orbital. If it's a 2, it's a d orbital. So, and then 3 would be an f. But anyways, so effectively what we're saying here is that your principal, which is, of course, your n, is where the shell is. But then within that, we're wondering the subshell, is it an S or a D, depending, as long as you're not in like n equals 1, then you're going to be seeing that as either a subshell of an S or a P. Now that we know that we're in the P, we have a P subshell. Now, magnetic is going to be integers that range from negative to positive, depending upon the subshell, meaning that if you have an S, there's only one possible option, because effectively what this would look like, you have your S, your P, your D, 1, 2, 3, 4, 5, 0, this is minus 1, 0, 1, minus 2, minus 1, 0, 1, 2. And, and so on. F would go down to minus 3. So it's going to range basically from with your orbital orientation. It's going to range depending upon what subshell you're in. And then the spin is, this is your magnetic, otherwise known as your which orbital are you in. And this is going to be from minus n to, or minus integer to positive integer with 0 in the middle. And then depending upon the shell. And this is your spin. This is just simply asking, what is the electron orientation? So is it a positive or negative? So electron spin is either going to be plus 1/2 or minus 1/2. Okay, so again, remember when we're looking at like your electrons, that let's say we're going into the third group. You have your S, you have your 3s, your 3p, as we go across with increasing energy. Each one of these, because we're going higher and higher in the different orbitals, you're going to give it a different number. So in this case, if you have an s orbital, L equals 0, L equals 1, and when you have a p, L equals 2 when you have a d, L equals 3 when you have an f, so on and so forth. So 3d, 3d, 3d. It doesn't really matter that 3's there right now. This is just for example of the L. Okay, so those are your first two pieces that you need to know. So we talked about your principal, angular momentum, your magnetic quant number, and your magnetic spin. And again, remember, like I showed here, that when looking at energy levels, it's going to be, S, P, D, F, and then possibly G. So remember that there is that difference when it comes to the energies of your groups. So, what's important to note? Let's just go back to L. If we have an L that equals 1, that means it is going to be in a p orbital. And so L equals 1, but does that mean that n, because L equals n minus 1, that this is only going to be 2? No. I mean, it could be 5. n could equal 5 and then your L could equal 1, that just simply means that you're in the 5th period, or your principal number is 5, but you're specifically looking at the p orbital for whichever element you're looking at. So remember, you can write a set of 4 quantum numbers for any electron in its ground state in any atom. So we can use that to help understand where we are at. So essentially, you can identify an element based off of these numbers. But before we do that, I just want to reiterate that this note where we could even make a graph. So n, meaning like when you're going down your periods, you go down to period 1, period 2, period 3, period 4, 5. Well, what are the possible L's? So n minus 1, it's got to be 0. So this is only going to be the case for hydrogen and helium in their ground state. But n minus 1, so we have 1 and 0 for 2, 2, 1, and 0 for 3, and then, just like we talked about before with electron configurations and Aufbau, Pauli exclusion principle, Hund's rule, we have these different levels that you're going to be able to, take a look at when it comes to the orbital shapes. However, this is going to also be useful when we focus on the ability to look at your magnetic and your spin number, as we know because of Heisenberg's uncertainty principle that electrons take up space and time. But again, 0, so S, this could be an S or a P, this is SPD, SPD F, and so on and so forth. So what you can do, you can look at an example, like we said 2P, and I said, well, what is the N? The N is that number there. It's saying that we're in the second group, but then you see that P. Now we know that a 1 is going to be the L for a P orbital, right? I mean, these are not right in the right same order, but 0 is S, 0 is S, 1 is 1 is P. So then that means in this case N equals 2, L equals 1. So if this was 2S, then N equals 2, L equals 0. So let's try maybe a little bit more complicated. Not really, but let's say 4F. Okay, well, N is easy. N equals 4, because it's right there. Now F. I would think 0 equals S, 1 equals P, 2 equals D, 3 equals F. So then that means L equals 3. That's it. I think they make it a lot more complicated for some reason. But anyways. So again, let's talk about, so we talked about ML is going to be your orbital at the sublevel, and then your MS is your spin. What electron due to the uncertainty principle? But remember, with this number is always going to be 1/2 plus or minus, because an orbital can only have 2 electrons. Just 2 electrons, never more, never less. Well, I mean, it could have less if it wasn't filled, but 2 max. So we can say since L equals 0 and this equals the s orbital, then ML is 0 too, because there's only one possible orbital to fill. So just remember that too. But here's what's kind of cool about this. You can actually use this, and I'm sure your professor or teacher may do this to have some fun with you on a test, and it takes a moment, but once you practice enough, you get really used to it. You can actually identify an element using this. So what if I said N equals 3, L, I'm just making this up, so hopefully this goes well, L equals 2, and then make sure I'm not going off the camera. Again, I'm doing this on top of a bug zapper box and some textbooks because I haven't gotten a proper setup. But I said I was going to help, and damn it, I'm on top of it. I digress. So ML, say, equals -1. So this is going to give us a little bit of information, and then we'll say MS equals -1/2. So, mind you, this is assuming that we're starting with positive charges first. So it just mean that's your positive charge, your negative. Let's say we're starting with up charges first. So N equals 3. tells us the period. So we now know that we're somewhere in the third period, and then L equals 2. So remind ourselves, what does that mean if we have L equals 2? Well, that means we're in a d orbital, right? Again, 0 equals s, 1 equals p, 2 equals d. So we've got our 5 orbitals, and then we see ml minus 1. Okay, so that to me is saying, well, we're looking at this, because the ml, I'll say this is ml number, make sure you can still see that, minus 2, minus 1, 0, 1, 2, and we'll say plus. So we're looking at this one, and then we have a minus 1/2 charge, meaning that if we're starting with positive, we can count and go 1, 2, 3, 4, 5, 6, 7, because we're specifically interested in the negative charge on the electron in the magnetic number for the orientation for D. So that means it's this one. So what that tells me is we know it's 3, we know it's D, and we have 7 electrons to be there. So it's 3D with 7 electrons. So then you go and look at the periodic table, and you ask yourself, well, where would that sit? What could this possibly be? And you would find that that is going to be, I got to look at a periodic table really quick. Chromium, I think. Let me make sure. So you have your third group. Let me see. I gotta get a better one. Cobalt. Yeah, cobalt. So that's your cobalt. Because you can look at, when you look at the periodic table, cobalt is going to be your 7th electron in once you're in the 3D orbital. So that's cobalt. Okay. So hopefully that made a little bit of sense. Hopefully that wasn't too bad. I can't forget the charge. So yeah, so that's that there in a nutshell. Hopefully it's not too complicated, and there's just maybe even do some practice problems with yourself. Like I will sometimes just say like, all right, well, let's think about the principal. Like if the principal equals 3, well, what are the possible values then for L? In my head, I would have to say, well, I know that L is going to be n minus 1, so that means it must be 2, 1, and 0. And then, well, now think about that. What happens here with 2? If L equals 2, then what are your MLs? So now I'm thinking again, well, I know that this is going to be integers that range from positive to minus for that shell, for that n. So that means, oh, 2, that's a d orbital. So that must be minus 2 all the way to plus 2. And of course, you got minus 1, 0, plus 1. So then I think, okay, well, I could do that. Now, if I'm looking at this, and if I said that this has, 9 electrons, and we're starting with the positive, what would our MS be? Well, I know as we move across, if we start with positive, that MS is most certainly going to be a minus 1/2 at this point, because we're adding the 9 electron to the D, which can carry a total of 10 electrons. So it'd have to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know that. So hopefully that all kind of makes sense. I hope it does. And so you can use a whole bunch of these, you can use a whole bunch of these to answer some questions. And yeah, let me know if you have any questions. Hopefully that made a little bit of sense and hopefully clarified anything you may not have understood.